right, this is lesson 5 for Unit 1, Middle School B. We are, in this one, we're talking about reducing fractions. We're kind of building up all of these puzzle pieces, and we're heading towards adding and subtracting fractions with like denominators. With unlike denominators, and we're adding in all of these some of these new things like integer rule. Well, new old things potentially, but either way, we're adding all these little pieces in and heading towards that topic. So we are just nearly there, but we're gonna talk about if you have a fraction that can be reduced. How do you reduce it? This is probably review. Like I've said that about a lot of things at this point in this course, and it's as is the case with pretty much everything else we're doing. If it's not review, that's okay. We're covering it in a detailed enough and a slow enough fashion that we can make it happen for you and you can be able to do what you need to do. So this is going to be one like we do with a lot of these. Oops, let me change my brush because that's a bad choice. How about this one? We're going to jump in with examples. What I was saying before I got distracted by brushes. Okay, so let's start out with an example. Let's reduce, how about 10 25ths? Now this is where we got to kind of do some thinking and some thought processing and all of those things. Excuse me. So we've talked before about finding the greatest common factor in a thing. So let's think through the greatest common factor here. Now you could do a factor tree like what we talked about before with the numerator and the denominator. We could split 10 into 5 and 2, which are both, that's not a 2, but that is, which are both prime. And then we could split 25 into 5 and 5, right? So the most common thing, the only common factor between these two is a 5. Now, you could take it that way. We're gonna look at one in a minute that has multiple different possibilities, and you can think about it as trying to find the greatest common factor. You can also think about it as just trying to find a common factor, and you can do it in multiple steps. This one really one is the same as the other, right? So in this one, we are going to divide the top and bottom by 5. I'm going to use this division symbol because this is middle school B. I think that seems like a good idea to me. So 10 divided by 5 is 2. And then 25 divided by 5 is 5. Now, when we're reducing fractions, we know that we're finished if we can't divide the same number. They don't have to be prime numbers. These do happen to be prime numbers in this particular answer choice. They're not always prime at the end, but they do have to be either prime, they have to be prime and or they don't have a common factor. So if they don't have a common factor other than 1, then we're finished. So there's our first example. We're going to do another one. Let's do another one. This one we're going to do a little bit bigger. Okay, so we're going to use some numbers that are a bit bigger. I think I'm going to change my colors so it's easy to see which problem we're doing. There we go. Number 2. Number 2, let's do, how about 56 64ths. Okay, so we're gonna, on this page, we may redo this exact same example here in a minute, doing it another way. We're going to do this the same sort of way. We're going to look at find the greatest common factor between 56 and 64, and then we're gonna, on our next slide, we're gonna look at it kind of a different way and a different approach. And all of those things in our next lesson, or one of our next lessons, we're going to look at divisibility rules and some kind of ways some tricks to be able to find something that goes into 2 numbers and all that stuff. But for now, let's just do this the same way. So 56. Now there are different things that go into 56. 7 and 8 go into 56. You could also do 2 and it'd be 25, 26, 27 maybe. We'll see in a second. But you could definitely do 7 and 8, right? And then we could do 8 splits into 4 and 2, and then 4 splits into 2 and 2. So there's the factor tree for 56. Let's do the same thing for 64. So for 64, I guess I could change to my lighter scratch papery looking color. 64, we could do, let's say we looked at this and said even, and said, okay, 2 goes into there. 2 times 32 is 64. Oh, look, 2 works again. We could do 2 and 16. We could do 2 and 8. And then we could do 4 and 2. And then we could go 2 and 2, right? So what's in common? They each have 1, 2, 3 2s. 1, 2, 3 2s. 2 times 2 times 2 is 8. So our greatest common factor is going to be 8. All right, so we can divide the top and bottom over here by 8. We're going to use this symbol because it's a good idea. Now, the better you have your multiplication tables memorized, the more likely it'll be that you can just look at 56 and 64 and say, oh, look, 8 goes into both of those already. So you may be able to, the better you have your times tables memorized, the easier these will be because you'll be able to identify numbers a lot easier. Okay, so we end up with 56 divided by 8 is 7. 64 divided by 8 is 8. One other neat thing, I don't know if you noticed this, but if we do the factor tree, you actually have what we end up with on the top and bottom. I'll show you what I mean. We have here, we have 7, see, for the top, and then 2 times 2 times 2 is 8. So you always have that as well. So there's several different, that's one of the things that we're wanting to kind of work towards is more and more number sense and more understanding how numbers work and putting all those pieces together. Let's do another one. I said we were going to do this one, but let's do a totally different numbers. That way we get some brand new examples, and we're going to do it a different way. That goes there. My colors are all mixed up, but that's okay. No problem. This is going to be example 3. Y'all don't really care what color it is. You just care what it looks like, right? And by what it looks like, whether it's legible and it maths in a good way. So let's do, how about 72 over 144? So let's say you forget about greatest common factor and you don't do the factor tree and whatever else, and you look at these and you're like, oh, okay, this almost can certainly reduce. What goes into both of those? And you're having trouble seeing something larger. Now, there's one that's kind of obvious-ish on this one, but let's pretend like you don't see one that's kind of obvious. It's 12. Sorry, spoiler alert. But let's say that all you see is the fact that both the top and the bottom are even. Okay, so you can do that. You don't have to find the greatest common factor to do reducing of fractions, right? You can do it even simpler than that. And you can do it this way. Now doing your factor tree might actually save you some time in the long run. But let's pretend like you forget that, or for some reason you just hate it or something. We see that they're both even, and all even numbers are divisible by 2, right? So we can divide the top and the bottom by 2. Now that we may have to kind of scratch paper ourselves. So let me kind of make me a little scratch paper area, because those are a little bit tricky, right? 2 into 72. 2 goes into 7 3 times. 3 times 2 is 6. We subtract. 7 minus 6 is 1. We bring down the 2. 2 goes into 12 6 times. 6 times 2 is 12. We subtract those, leaving us with 0. So it ends up being 36. So this equals 36. Now, this one's also a little tricky. Let's scratch paper it. Okay. 2 divides into 144. Goes into 1 0 times, goes into 14 7 times. 7 times 2 is 14. subtract those. 14 minus 14 is 0. Don't forget to bring down that 4. 2, you got to bring it all the way down. 2 goes into 4 is 2. 2 times 2 is 4. We subtract again, and we end up with 0. Now, so we end up with 72 in the denominator. Who'd have thunk it? Look at that. So we can save ourselves some time and trouble. Now you may see something else that goes in there already. You may have already figured out something like 6 goes into both or something like that. You may see some of those. You may not, right? And so let's say we just see 2 again, right? Now we've already got dividing by 2 on the bottom. That one we've already got in our scratch paper. See, that's one of the reasons why I strongly recommend to not erase your scratch paper, because very often, especially at this level, we end up reusing some of the problems that we've already done. And if you've already done the work, why do it twice? Okay, so what about 36 divided by 2? Let's go ahead and scratch paper that one. That one may be easier. You may be able to pull that one out of the hat without any trouble. We're getting smaller and smaller, but let's do it anyway. So 2 goes into 36. 2 goes into 3 once. 1 times 2 is 2. We subtract those and end up with 1. We bring down the 6. 2 goes into 16 8 times. And we end up with 8 times 2 is 16. Subtract gives us 0, right? So we end up with an 18 on the top. Now, you may look at this and say, oh, I've got my 9s really, really well. So you could also divide by 2 again. We could just keep on dividing by 2 until we're done, more or less. But you might look at this and say, oh, 9 goes into both of those because 9 times 2 is 18 and 9 times 4 is 36. You're like, oh, okay, let's get off the two train. You could do the point I'm making with, oh, you could do this or that or the other thing is there's more than one factor in a whole lot of numbers. A lot of composite numbers are big old conglomerations of prime numbers multiplied together, right? So there's more than one way. So you got to figure out whatever you see that goes into both. And the more we practice these, the more you'll get used to it and the more you'll see them quicker and easier. So 18 divided by 9, like I just said, is 2. 36 divided by 9 is 4. Now we look at this and we say, oh, wait, look at that. One more. Now, we probably could have figured the more you get number sense on this, as soon as we saw that 72 and 144, 144 divided by 2 is 72, we could have already jumped to 1/2 as our end result because we already kind of saw that. And that's really great to start getting that number sense in there. I decided to walk this one all the way through because this kind of goes to show that you don't have to see it. You don't have to see those things. Now, as we practice it, your number sense will go up and it'll get better and you'll be able to see those quicker and easier and it'll be really, really great. But if you don't see it, you can walk through as many steps as it takes to get all the way simplified. 2 divided by 2 is 1, and 4 divided by 2 is 2. So 72 over 144 reduces to 1/2. So those are some steps for reducing fractions. Kind of a couple different ways. It's really the same way. You can either start now. If we would have started with our greatest common factor, this problem probably would have actually taken less time. We would have kind of walked through parts of this as well. We would have kind of done half of it. We would have done 72, and then the 144 would have kind of just walked itself down because it would have been already with the 72, which would have been great. So that probably would have actually been faster in this particular problem, and that's a great way to do these. But if you forget about that or whatever, you can also just walk it through one piece at a time. All you got to do is find something that goes into the numerator and the denominator and divide it. And then if we can divide more. And you keep on walking until it gets as reduced as it possibly can be. We'll see you in the next one. Bye-bye.